Now, please look for it. The concept of monotonic functions. More commonly, these functions are known as increasing, decreasing functions. Increasing, decreasing functions, but their actual name is monotonic functions. So the complete thing that we need to know about monotonic functions. Now look carefully. Perfect example to understand the complete concept of monotonic functions is through this graph. The graph of the sine function in the interval 0 to pi. Perfect way to understand the concept of monotonic functions. Now look, this is the graph of sine function between the values x equal to 0 and x equal to pi. This value, that is, we know that sine pi by 2 is 1, and which is the highest value. The maximum value of sine is 1, which happens at pi upon 2. Now you can see that is for a function to be increasing. This is compulsory. As you can see, the value of x is changing from 0 to pi upon 2. So is the value of x increasing or decreasing?
Increasing.
From 0 to pi upon 2. It is
Increasing, sir.
increasing. So in the limit 0 to pi upon 2, the value of x is increasing. And what about the value of y? That is the value of the function. Is it increasing or decreasing? From 0, it has become 1.
Increase.
This value is also
Increasing.
increasing. That is, whatever is the nature of x, the same is the nature of the function. If we are increasing the value of x, the value of the function is also increasing. So this is compulsory for a function to be an increasing function. So for increasing, if x1 is greater than x2, this implies that fx1 should be greater than fx2. Or if x1 is less than x2, then it implies that fx1 should also be less than fx2. If the nature of the variable and the nature of the function, that is the nature of the domain and the nature of the function, if they are same, then we say that the function is increasing. Now, in the range pi upon 2 to pi, is the value of x still increasing?
Decreasing.
It is
Decreasing.
no. Pi upon 2 to pi, it is still increasing. From pi upon 2, it has become pi. From half, it has become full. So it is increasing, right? The value of the variable. The value of the variable is increasing. But
Okay,
the
sir.
value of the function from 1, it has become 0. This means the value of the function is decreasing. So on increasing the value of the domain, if the value of the function is decreasing, then we say that the function is a decreasing function. So for decreasing function, the simple theory is if x1 is more than x2, it implies that fx1 is less than fx2 or vice versa. That means x1 is less than x2 should imply that fx1 is more than fx2. So these functions are known as increasing, decreasing functions. Now the question arises that why we call them monotonic functions. See, if we consider the whole interval 0 to pi in this complete interval, the function first increased, then decreased, right? But that is, it is increasing also, decreasing also. If a function is increasing and decreasing in the same interval, I repeat, in the same interval, if the function is increasing or decreasing in the same interval, then it is actually neither increasing nor decreasing, because it has to be either only increasing or only decreasing. Like we can see that in the interval 0 to pi upon 2, the value is only increasing. In the interval pi upon 2 to pi, the value is only decreasing. That is, it is possible to divide the complete interval into sub-intervals, into smaller intervals, and in those smaller intervals, the function will have only one nature. It will be either only increasing or it will be only decreasing. And this is the reason we call these functions to be monotonic functions. That is a function which has got a single tone, which is either only increasing or only decreasing. So now we can understand these three things. A function can be increasing, a function can be decreasing, and a function is neither increasing nor decreasing. That is, it cannot be simultaneously increasing and decreasing in the same interval. So either it will be only increasing, it will be only decreasing, or it will be neither increasing nor decreasing. Am I clear with this much part? This was the
Yes, sir.
theoretical
Yes,
approach.
sir.
This was the theoretical approach for increasing decreasing functions. Now, the use of differential. By making the use of differential, we can even do one more thing. Like, I'll explain it to you. The function started from 0 and it has become 1. That is, the highest value of this function has been attained when x is equal to pi upon 2. That is, can we say that at this particular point, at x equal to pi upon 2, the function is not changing now. That is, this is the turning point of the function. So the function will attain either the maximum value or the minimum value at the turning point. For an example, if you throw a ball up, it will keep on going up. The moment it reaches the maximum height, it will, for a fraction of a second, or maybe less than that, it will just stop there. That is, after attaining the maximum value, the moment it reaches the maximum value, it will stop. And then it will start falling down. That is, it has attained the maximum value, and after that, it has started decreasing. So if we include the maximum value also in the function, then it is increase. But if we exclude the value, because at this point it is no longer changing. See, we use ing form of the verb when something is in continuation. But at pi upon 2, that is when the function has attained the maximum value, it is no longer changing. It has attained the maximum value. So in such a case, if we exclude the maximum or the minimum value, then we use a special term. We call it strictly increasing or strictly decreasing. So there are 4 things in all now. Increasing function. Then there will be strictly increasing function. Then decreasing function. And then there will be strictly decreasing function. So when we make the use of strictly increasing or strictly decreasing, that is when we use the word strictly, what we do is we exclude the extreme values. Exclude the extreme. And what a coincidence that the extreme value will be always at the point of that is at this particular point, the value when the value is either maximum or minimum. If we draw a tangent at this point, the tangent will be parallel to x-axis, and the necessary condition for a tangent to be parallel to x-axis is that its differential should be 0. So अगर हम उस वाली condition को exclude कर देते हैं, so it will become strictly increasing or strictly decreasing. To be precise, whatever we have discussed, इसकी summary सिर्फ इतनी सी होगी that for increasing function f dash x is greater than or even equal to 0. But for strictly increasing, it will only be f dash x is greater than 0. For decreasing function, f dash x is either less than or equal to 0. Now, for strictly decreasing, we need to exclude the extreme value. If we exclude the extreme value, it will be f dash x is less than. So these are the 4 things, and this is the complete, that is mind mapping, which is required for increasing decreasing function. If you have any doubt in whatever we have discussed just now, please ask.